To have convincing physical behavior, a game object must accelerate correctly, have a feeling of proper mass, and be affected by collisions, gravity, and other forces in a realistic way. Unity's built-in physics engines provide components that handle these physical simulations. There are two separate physics engines in Unity, one for 3D physics and one for 2D physics. The main concepts are identical between these two physics engines, except for the extra third dimension in 3D physics. These systems are implemented, however, with completely different components. When using 2D physics, the Physics 2D components will seem familiar to those who have used the 3D physics engine. Most of the Physics 2D components behave in a similar way to their 3D counterparts, except in 2 dimensions, and have similar names except with 2D after the descriptive part of the name. For example, in 3D physics there is a rigid body component. In 2D physics there is an analogous rigid body 2D component. This pattern will hold true for most of the Physics 2D components and scripting methods, including Box Collider and Box Collider 2D, or OnTriggerEnter and OnTriggerEnter 2D. It is important to note that these two physics systems are comparable, but not compatible. 3D physics and 2D physics can be present in the same scene, but they will not interact with each other. There are some important differences between 2D physics and 3D physics. The most critical difference is that there is no concept of depth in 2D physics. All 2D physics plays out on the xy plane, with this 2D plane at 0 along the z-axis. Game objects under control of the 2D physics engine can only move on an xy plane and can only rotate around the z-axis. As it is possible to view a 2D game when the editor is in 3D mode, and it is possible to change the transform position Z of a game object that is using 2D physics, it is important to remember that all of the physics interaction takes place at the z-axis position of 0. 2D physics has a number of project-wide settings. These can be edited by selecting Edit, Project Settings, Physics 2D. These settings contain details on the properties like strength and direction of gravity, the default material, and the layer collision matrix, and more. For more information on the Physics 2D settings, please see the information linked below. One of the primary components used in Physics 2D is the Rigid Body 2D. Attaching a Rigid Body 2D component places a game object under the control of the 2D physics engine. The Rigid Body 2D component works with colliders to detect collisions, can receive forces and torque, operate various types of joints, and other specialized 2D physics behavior. This component is also used to keep track of important physical properties about the game object the component is attached to. It has properties for the object's mass, linear and angular drag, gravity scale, and many others. For more information on the Rigid Body 2D component, please see the information linked below. Every 2D project has a default value in the Physics 2D setting for gravity. Gravity will affect all game objects with a rigid body unless that rigid body is set to ignore gravity. This is done by setting the gravity scale to 0. Any other value for gravity scale will be used to modify the default value for gravity, and this can be done on a game object per game object basis. If the game object has a Collider 2D attached, it can participate in physical collisions or trigger events. 2D colliders allow game objects to have physical shape or presence in the scene's 2D environment. There are several types of 2D colliders that work with the Rigid Body 2D. The circle, the box, the edge, and the polygon collider. Each collider type has a different set of behaviors and can be used in different circumstances. For more information on the Collider 2D component, please see the information linked below. When a game object has a Rigid Body 2D attached, it can use one of the several joint 2D components available. When using a joint 2D component, the game object can participate in complex and specialized physical behavior, like hinges, springs, sliders, and couplings. 2D joints allow a game object to be anchored to either a point in the scene or another game object and react physically to that anchor. In some cases, several game objects with a joint 2D can be attached to each other for more interesting and complex behaviors like chains. For more information on the joint 2D components and how to use them, please see the information linked below. The surface properties of a Collider 2D are defined by a special type of material. This material is the Physics Material 2D asset. A Physics Material 2D is used to control the friction and bounce that occurs between two game objects with Collider 2D components attached when they collide. To make a bouncing ball or slippery ice-covered platform, use a different Physics Material 2D on each game object. For more information on material assets and physics materials, please see the information linked below.